Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about spy balloon. This became a hot topic very recently, so let's understand it. So the puppy we are talking about is stratospheric atmospheric balloon that we are talking about. It's like a specific type of very high altitude balloon that goes some high places. And stratosphere is around 10 kilometer to 50 kilometer. That's the zone. And balloons generally achieve around 18 kilometer to 37 kilometer. That in feet translates to around 60,000 feet to 1,21,000 feet, 100k kind of feet. Now be mindful, the world record is around 50 kilometer, but that's generally not achieved with any sort of meaningful payload. So that's the whole point, and it's a very stable platform. Even though it looks like it's a balloon, the fact that it's such a high up that majority of atmospheric turbulence is below it, meaning from its vantage point it's stable. Like if you are hanging on a gondola, you're like, dude, everything is calm, everything is chill. It's like very calm. And at that location, you also have the luxury of, if you go a little bit up, you get calm and high speed jet stream, meaning you can move from A to B quite effectively and quite fast also. Meaning you can go places, like you can launch from A country, go to B country quite easily while expending very little amount of energy. So it's very useful in that regard. And they can stay in one area. Be mindful, they cannot stay in one spot, meaning if you put a actual three-dimensional location of it, it's not going to be like, I'm here. It's going to be like something like this. It cannot stay in that one exact location, area-wise. So that area nowadays can be very tight, but still has to physically move. It's not a satellite, it's not a geostationary thing. Now, from all communication point of view, all data collection point of view, camera opticals point of view, it's more or less static. So that's not that big of a deal. And in the early days, as in around 2005 to 2010, people wanted to use this puppy as high altitude pseudo satellites. Basically, Google's Project Loon also caught up that wind. Now, be mindful, the reason why these things are no longer looked at as pseudo high altitude satellite is simply because it should have been tried as early as around 1980s. Then it would have made sense, because right now satellites are cheap. And not to mention, that simply happened because of SpaceX, but it did happen. The fact that we have 2,000 to 3,000 satellites in one constellation active at this point in time, and the fact that we are moving to a world where our mobile phone will become a proper two-way communication, satellite communication quite soon. So these things no longer hold that sort of value. And be mindful, these can only stay up for limited amount of time. Best case scenario, few months. Do not expect them to last for years or years. So satellites are at this point in time where it's like much cheaper, much more robust, much more practical, much more scalable option. That's why these sort of projects faded out. Can it be done? Yes. Should it be done? It's kind of pointless. You can try it, but it's like not that useful. So what about this platform? Now this platform are never filled to the maximum capacity, meaning if you calculate its liter capacity, like fully stretched, it would be a lot. But will they ever fill that much helium or hydrogen into it? No, they will only fill, of course, the calculation, because be mindful, this balloon looks like it's fully stretched out, but generally it has very little strain on it. At its final altitude, the strain on it should be very little, because be mindful, to make sure this huge balloon can actually lift up, the wall thickness has to be kept as thin as possible. To keep the wall thickness, as minimal as possible, it has to be under low pressure. So they fill it up enough that it can actually fly. As it goes up, it expands. Basically, high altitude makes it inflate. Not that you are inflating it, high altitude is making it fully inflated. At that point in time, it reaches its fully complete position. At that point in time, it has very minimal stress. Basically, the walls, it's not under high strain. So you cannot pop it. You cannot be like, boom, that will not happen. It's very low strain on that point in time. And generally for a pseudo satellite sort of system, you will have second bladder here. Now that bladder creates a small area. That area you can fill up with air generally, and you will have a vacuum pump that will pump air into it to increase its weight, to drop it in altitude, and then it's going to have a deflation valve that it opens to basically let it become lighter again, go up. So that's how you go up or down. Now, even though it says compressor, if you actually look at it, it looks more like a vacuum pump, simply because it's designed to work at very high altitude, as in like 60,000 feet. So PSI at that point in time is around 1.5, actually even lower than that. So it does basically allow you to go up or down, and that's how it controls itself in terms of movement. It will detect like where is the jet stream that goes in the direction where I want to. Generally it will be layered like this, like one is going in this way, one is going this way, that another is this way. So it will use its altitude controllability to basically piggyback onto a jet stream and then go where it needs to go. So it does that. Now be mindful, this can only be used few times, because again, very thin membranes, everything is as minimal as possible. So do not expect, oh, I'm gonna control this and year on year I'm gonna stay in the air. No, like months best case scenario. So it can be done few times, but do not expect it to be like continuous 24 into 7 into 365 thing. And it can carry few tons if you are filling this puppy up with helium. So few tons, and you will be like, okay, if I'm doing it for short duration, why not put hydrogen in it, get more power? Hydrogen and helium do not have that big of a difference. But if you use hydrogen, you do get this penalty. Penalty is this puppy leaks, meaning if you use hydrogen in this, it's going to leak very quickly. So something that can stay in the air for 4 months will barely last there for around 1 month, barely. So that's why hydrogen is not used. It can be used, it's just unwise. Basically, you want to waste it. So with few and mathematical actual difference is very tiny, so it does not justify it. And you can add solar panels for a few kilowatts of power, so it's actually quite tangible and comparable to a satellite. And it can even have batteries to give you 24 into 7 operation. And be mindful, majority of the clouds are below it. So when sun comes up. There is no like, oh, cloud, rain, no. It's like you can have a very good reliable clock system where it's like, no, this will work 24 into 7 reliably using solar. Exactly how satellite works. And the Chinese spy balloon, basically the puppy that made this noise, supposed to carry around 3 tons. That's approximate calculation, but they should be able to carry 3 tons. Be mindful, there are very few satellites that are above 3 tons. 3 ton is huge. And in terms of solar panel, it had the ability to get around 4 to 6 kilowatts of power. Again, it could get even exponentially more if they were using multi-junction solar array. The likelihood was low, but again, only the people who were in the fighter jet that actually get to see it, they know, but everyone else does not have that luxury. Again, you can do that, like it's your choice. If you want to really increase the power, you need that power, you can add multi-junction solar array which has silicon, gallium, things of this nature to give more efficiency. Rather than limited to 21 to 25%, you can go to 30 to 35%, or maybe even tri-junction one that can go to 51% efficiency. That means even for fewer weight, you will have exponentially more power. But again, cost will become very high, very high. It's only used for military satellite, not even basic satellite, military satellites. Very expensive thing, but it can be done. So do not be like, oh, if I only had 5 kilowatt, I could do amazing things. Yeah, you can get 5 kilowatt. It's expensive, but you can get it. So what about China? Now, China has a whole network of this ecosystem of basically having weather balloons acting as a pseudo satellites. Why? Well, satellite generally beats this in 100% of the time. Then we're like, why the heck they are using it? Well, to beat it with satellite, you need what we call LEO satellite constellation. One satellite will not do it. That's what everybody talking about. Like if you have one satellite, it's like useless. But if you have a constellation, basically how the heck GPS works all the time? Because it's a constellation. How the heck Starlink works? It's a constellation. That's what you need. Basically, if you have a constellation service, then you can truly observe a place. And be mindful, because satellites can stay in orbit. Even in low Earth orbit, they can stay there easily for 10 years. That's a very good tool, even though expensive, but very good tool. Because again, if you are observing your enemy country, countries do not change overnight. It's not like, oh, in 5 months something big happened. It's like it's a slow progress, and you really need to observe the slow progress, because if you're seeing a random village and randomly its population is growing, something has been done. Like there is a very good chance there could be underground construction going on. It has happened. Like that's how people are trying to hide things from satellite. So and that's why you do need long-term data gathering. For that, you need satellite constellation. So you can have 24 into 7 into 365 coverage, but that's expensive. So from that point of view, it does make sense. And if China ever wants to launch this puppy into India, the best time to launch is in Sawan. Basically, it's a cloudy weather scenario where we have a lot of rain. Like sometimes we can have rain for 1 month. So in those sort of time, it's nigh impossible to detect, because again, cloud are white. This puppy is white. So it's very hard to detect. And at night, nope. At night, it's nigh impossible. Because even if you are like, hey, what about there is full moon and it's reflecting? Moon would be such a high contrast compared to this. It will be very difficult. Like if you are looking at, if you have detected it and you are focusing on it, yes, you can do. But just as a like, oh, I'm looking, oh, wait a minute, there is a thing. That's very unlikely to happen. So it's very stealth, very different kind of stealth. What about radar reflection? Does it have radar reflection? Yes and no. Now, majority of the balloon, it's completely invisible to radar, because again, it's very low density. Radar wave just goes through it. What about the gondola, that 3 or 4 ton thing? Of course, that has radar reflection, but because of the surface area and the geometry, the reflection is very uncharacteristic. And every time you see a radar detail, basically a screen, you see the data, computers have already done a lot of filtering. So the reflection of this puppy goes into that filtering data, meaning the raw satellite, raw radar could detect it, but it does not know what's looking at. Unless you train a radar system, algorithm, filter, all that, specifically detect this, specifically use very short wave spectrum, it will be very, very difficult to detect it. Not impossible, but very unlikely, and not to mention most commercial system cannot detect it. And what about heat signature? Again, it does have some thermal characteristics. Basically, it's completely different from ambient, but not that much. Basically, if you have a cheap heat seeker, it will simply not work. Flat out. Cheap radar lock, cheap heat seeker, bye-bye this. This is like, bro, I'm invisible to those things. It's like, if you remember Iron Man 1, there was a scene like F-22 was like trying to chase Iron Man 1 in Mark 2, no, Mark 3, and they were like, why the heck, you can't detect it. Is it stealth? He said, no, it's not stealth, it's tiny. Same thing, it's tiny. So it's very hard to shoot down, very hard to stop. Basically, you cannot be like, do not enter in my airspace, and very difficult to jam. Not impossible, but difficult. But it does give you some side effects of low controllability and weather dependability. Meaning, because weather can decide whether it's like, it's going to cooperate with you or not cooperate with you. It could literally be like, China could be like, I'm going to spy on India. It sends hundreds of balloons, and someone helps us and was like, nope, nothing. They can't do anything. You can control your altitude, but you can't go against the wind. So even that tiny propeller, that's tiny. It's inherently there just to go around and around to stop. It cannot fight against jet stream. So it is weather dependent, does have low controllability. And this was basically their hypersonic glide vehicle test, where they used a high altitude balloon. They uploaded it in TikTok. You want to see what China is doing, go to TikTok. And they dropped it from very high altitude. I'm pretty sure this was made as light as possible, so gain as high altitude as possible. Because again, same balloon, you can increase the altitude from 65,000 feet to much higher if you reduce the tonnage that you are hauling onto it. So if you have higher quality equipment, made it 1 ton, it can go like 80,000 feet or maybe even 100,000 feet. So for this, they must have made sure, because again, that's how they will get the acceleration data, control data, thin atmosphere reaction, all that. So China is doing a lot of it. Be mindful, this is not new, this is not unique, every country does this. Even European Union was using this sort of puppy for immigration crisis during where a lot of small boats were carrying a lot of immigrants. That's what they were doing. That's how they were studying oceans. So what did USA do? Well, the moment this balloon entered US airspace, US knew about it. It was not like, ta-da! It's like they knew very well on, and generally they have good enough network where they're like, they know, at least enough, but they are nearby, they know. So the moment it entered it, they deployed their jets, went there, studied it, then they deployed basically U-2 plane to properly study, and then they deployed the big gun. This is the big gun, basically Boeing RC-135. Now this puppy was shadowing and jamming it. And if you have heard, like when this event was happening, is that they're using the spy balloon to spy on China. This is what they were doing. Basically, this puppy is so loud, it can jam any signal that is going away from it. And because again, it can directly chase you. Again, it does not need to be at the same altitude. It's like, oh, I can see you. It can jam that data signal and observe every signal that you're sending. So it can study your frequency. It can study your coding method. It can figure out a lot of things about you. So the spy becomes spied on. So this was deployed, and to show off to the world, because F-22 is never got its like a true moment to shine. They're like, just to show off that the fact that F-22 is a fighter jet can actually go into that high altitude and do combat maneuvers. That's a big deal. This sort of altitude, that anything 60,000 feet plus, not doing, like SR-71 cannot do combat maneuvers. Be mindful, like if it try to turn, it will take time to turn. SR-71, it can do at Mach 3, but it will take very sweet time. Same with U-2, they're very sweet time. But this puppy can do combat maneuver at 60,000 feet. That's a very big deal. There are very few countries that have fighter jet that can operate at 60,000 feet, let alone they can do reliable maneuvers there. That's a very big show off. There's like, for people who understand what they are seeing, they're like, damn. Because yes, you can have fighter jet that just ballistic trajectory itself up and then goes there and then comes down. That is doable. But to actually be like, hey, this is my altitude, baby. I got this. My aerodynamic surfaces will work at this rarefied atmosphere. That's a big deal. That's a very big show off. Then it also a very good show off for their missile contrast based detection. Meaning it did not detect a heat signature. Again, there is no jet engine here, but it detected contrast. That's a very good algorithm for it to be like, oh, I see what I'm supposed to lock at, and I'm going to lock on it, and I'm going to boom it. And they boomed it. And it actually hit the gondola part rather than the balloon part. So it was like, from a US point, like a show-off point of view, that's a very big thing, because everybody was like, dude, how the heck they used a heat-seeker missile? Again, they used a contrast-seeking mode. Rather than heat-seeking, they used a contrast-seeking mode. It's quite amazing from a missile system point of view. Amazing. And why can't you just go pew, 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 pew on this, America on this? Well, here's the deal, differential pressure. The differential pressure, basically pressure inside the balloon versus the outside, is very tiny. The gap is very tiny. So you're talking about maybe 2 psi difference. So even if you punch a hole, it's like very slow air. If on Earth it's like boom, but there it's like, So it will take hours, hundreds of bullets, it will take hours. Basically, you have to make it Swiss cheese and still it will take very long amount of time. They have tried it in past, that's why that was not done. They have learned it the hard way. It's like, bro, these things are ironically bulletproof. So they're like, no, let's not waste time on this. And not to mention, for that much amount of firing, you have to make sure your jet is there. And again, modern jets are not designed to have gun as like a continuous method. It's like, it's like, basically maintenance staff would be like, why do you hate me? So they figured it out. It's like, it's not going to happen. As a show off, it's a very good thing. So what about how do you counter it? Meaning, again, China is doing it to the whole world. So how do you counter it? You can't counter it because, again, if China actually made it even lighter, rather than having 3 ton, it could have easily gone to much higher altitude. At that point, even F-22 would be like, maybe F-35 have even higher ceiling, maybe 80,000 feet ceiling, maybe that could have done. And maybe missile could actually have guidance system that can guide it for that altitude. Maybe, but it would have become exponentially difficult. That increase of from, like, say, 60,000 feet to 70,000 or 80,000 would have made exponentially difficult. Meaning even USA would have been like, okay, let's just figure out what to do. It won't be like, just launch this. It would be difficult. And cost ratio was horrible, meaning they spent around roughly $2 to $3 million to pop something that were costed around 100K to China. So it's like a really, really bad. And again, from that point of view, it's actually a great tool. China can just send hundreds of it and just waste everybody's ammunition and fuel and flight hour and maintenance hour and all that jazz. Is amazing. It's almost like as stupid as like Putin firing hypersonic missile on Ukraine. It's like, oh, you fired a hypersonic missile to boom something that you can do with cheap cruise missile. What's the point? So same thing, economics matter. So how do you defend against this? Like, everybody's like making this so difficult, so hard. Not really. We have these puppies, lasers. Basically, lasers are the best way to bring them down. Simply because, again, while these lasers are not powerful enough to do any significant damage to aircraft, it can do a lot of damage to tiny polythene that are used as a, like, outer cladding. It's super easy to poof it out of existence. At that point in time, lasers, I'm talking as low power as like 100 kilowatt of laser output, meaning even at worst case scenario with the targeting computer, everything can be fit inside one 18-wheeler. And there are some design from Lockheed Martin that are like 300 kilowatt unit, and that is like 8x8 wheeler that USA uses for transport, logistic transport. It will look like same size as HIMARS rocket launcher systems. So very small, but you can have enough power to poof it. And not to mention, power consumption would be manageable. Basically, even on remote location is manageable. And if you're connected to grid, that's like continuous power. 1 megawatt, 2 megawatt, that's like tiny. But you do need multiple lasers. You cannot, it's very difficult to do it from one laser. And not to mention, same thing will happen. If you did not directly hit gondola and it's like reacting poorly to it, you will have an uncontrolled scenario. You want control scenario. So you need multiple lasers to simultaneously poof it out of existence. But you also need multiple spectrum. This part is expensive. Majority of the laser system you see generally have one laser design, meaning they're using carbon dioxide. At that point in time, they may be infrared based. Some are ultraviolet based. You need mix of them. The reason for that is if you do not mix them, basically infrared, red laser, blue laser, ultraviolet laser, whatever have you, it's very easy to counter. You're like, if they figured out, like let's say China figured out, hey, India is like deploying hundreds of this, and India's like, we are using our, very good CO2 lasers. They're very energy efficient. We can run them for a long tower. They are a lot powerful, and it's infrared. At that point in time, they're like, coat it with a thin layer of gold. How thin? Few atoms thin, meaning you will not be able to see it that there is gold on top of it, and it will reflect majority of the laser. And that's how we do laser cutting. It's like, how the heck mirrors are reflecting, not getting fried. Again, mirror have gold coating, few atoms thin. So for that reason, you have to have multi-spectrum. At that point in time, you can poof it, guaranteed poofing it, because you cannot layer multiple things on. If you layer it, it heats up. Like, oh, you are hitting with a blue laser. Let's say aluminum is awesome at reflecting it. Ultraviolet will heat it. If you put gold, gold will be poofed by blue lasers. So that's why you have to mix it. Single coating can easily reflect monochromatic system. And laser, if you mix laser multiple sources, you guarantee it booming and guarantee jamming also, because again, it's inherently upside. That's from Israel. So it's upside down from their point of view, so you can easily block it. So all your sensitive site, quote unquote, they can actually have very cheap lasers output that are just blocking it. So from their camera point of view, that pixel would be cooked over time if it's low power. And not to mention, this can actually do the same thing with satellite also. So if you're like, hey, I want to make sure that American spy satellite does not go over India, lasers. They have to turn away the satellite, because again, you cannot damage the satellite that easily unless you increase the power exponentially, but you can easily fry any sensor. Sensors will be like, bro, I'm out. So they have to turn away, otherwise sensors poof. So that's how you're supposed to counter it. I'm like, many people are like, oh, how the heck you gonna counter it? It's unbeatable. Yeah, lasers, we have it. It's old technology now. We just need multiple of it, small enough unit, and if they are working as a collaborative unit, done, problem solved. They can send 100 of it. It will cost them more to send than us to counter. And that's one thing about weapon system. Every weapon has a counter. Every single weapon. Physics is like almost law of nature. There will always be a counter. So this was my presentation on spy weather balloons. Hopefully you have liked it, learned from it. In that case, please click the like button, share it among your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.